Okay, in this video, we're going to go over how to solve non-right triangles using something called the law of sines. Now, there's actually another law called the law of cosines, which I'll do in a second video, but for right now, we're just going to concentrate on the law of sines. And again, these are to solve non-right triangles. Now, let me just do a quick review. You may remember that if you have a right triangle, okay, you can actually use just the regular trig functions, trig ratios, right? You can use the sine as just the opposite over the hypotenuse. You can find the cosine of any angle, and that would be just the adjacent side over the hypotenuse, depending on where the angle is. And you can use the tangent to do the exact same thing, okay? Opposite over adjacent. However, these functions do not work for the other two types of non-right triangles. Now let's briefly go over those. Remember that there are acute triangles where every angle is less than 90 degrees, okay? Every angle is less than 90 degrees. If you remember that. And then you have an obtuse triangle where one of the angles, in this case this one right here, where one angle is greater than 90 degrees. Okay. Which again means that the other two angles again have to be acute. So remember, the difference between the two, in an acute triangle, every angle is less than 90, and in an obtuse angle, one of them is greater than 90, the other two are even smaller acute angles. Now let me show you, well actually let me just go ahead and tell you what the law of sines is. Now, just like over here, that there is a relationship between the sides of a triangle and the angles, the same is true for these kind of triangles. And the law of sines says this, that the sine of, let's say, angle A, actually let me just go ahead and do this real quickly, ABC, let's go ABC here as well. And remember, opposite, usually you're always going to use like the smaller letter. So opposite side of angle A would be like small a, small c. This would be small b. Okay, same thing over here. This would be A. The opposite would be B. The opposite would be C. Now, the law of sines says this, that the sine of angle A, the angle A, divided by the side A will be equal to the sine of angle B divided by the length of the side B, and that's equal to the sine of angle C divided by the length of C. Okay, so that is equal to that, is equal to that, and you can also just flip these around, quite honestly. You could just do this as well. Okay, and this last one as well. So you can use it basically any way you'd like. You can have the sine on the top, this length of the angle on the top, length on the bottom, or the length on the top and the angle on the bottom. Now let me show you an example of how I would use this. So here's a non-right triangle, and this would be an acute triangle, right? Because 60 and 70 is 130, which would make this equal to what? If that's 130, subtract 180. 180 minus 130 gives me 50. So now I have all the angles in this particular triangle, right? Now let's say I want to find side C and side B. Remember, I just said that I could take the sine of, let's just take angle A, all right? So sine of 60, the opposite of A would be 10, and that should be proportionate to, if I'm trying to find C, for example, sine C, or let's say it's sine of 50, put the degrees in there, over C. Okay, so now I need to use my calculator. And what is sine of 60? So sine of 60 turn it on actually, clear it. So hit the sine button, 60. And that's equal to 0.866. So step 1, step 2, 0.866 divided by 10 should be equal to the sine of 50. Let's go ahead and do that. Sorry about the glare. Sine of 50, 0.766, and that's going to be over C. Okay, let me just make this a little bit bigger so you can see it. Okay, let's go ahead and do cross products. So that times that gives me C times 0.866, 10 times 0.766. Move the decimal place over 1. So step 4. And then finally divide both sides by 0.866, and that should give me my answer. Let's see what we do here. So C will be equal to 0.766, or 7 rather, let's go ahead and get that better there. So 7.66 divided by 0.866, 8.845. So C would be equal to 8.845. Okay, and let's go ahead and pinch that back down again. And let's put that in there. 8.845. And since it's an exact number on my calculator, I might as well just use the exact number here. Okay, sometimes a teacher will let you round down, depending on the number of significant figures. In this case, we have 2, so I guess you should go down to 2 here, which would be 8.8. Okay, now let's just go ahead and do the same thing with finding B. So here we were finding C. And here we're going to find B. Remember, solving for a triangle means you're solving for all the angles and all the sides. So let's find B. Again, we can use whatever ratio we want to do. So let's just go with, the sine of 60 over 10 should be proportionate to the sine of 70 over our unknown, which is B. All right. We already know that the sine of 60 is 0.866 divided by 10. We know that the sine of 70 0.940. We'll do cross products. It gives me B times 0.866 is equal to 10 times 0.940, which is 9.40. Let's divide both sides by 0.866. 9.40 divided by 0.866, and I get 10.855. And there he is. And that is how you use the law of sines to solve for a non-right triangle. Now, there is one last caution that I want to give you. Whenever you are using the law of sines, it only works when you have the following types of information. When you have angle, angle, side, or angle, side, angle. Now, let me show you what I mean by that. If you go back to our example, my original information, as you remember, I knew this angle, and this non-included side. Remember? So this would be angle, angle, side. I could have also had angle, side, angle, and I could have also used the law of sines to do this one. If I would have known two sides and an angle, I would not be able to use this, the law of sines, and I'll show you that in the second video, okay? So I hope that was helpful.